First, let's talk about what E means. It goes like this. If we have one unit of object growing at 100% per unit time, then what would it be 1 unit time later? Seems easy, should be 2, right? Of course, that's too good to be true. The trick is with the growth rate. It's related to natural growth, which is continuously growing. Let's use an example. Say we have 1 unit cell. A bit later, it grows by a tiny bit. In the next little while, both the mother and the kid will still be there. The mother cell will give birth to its second kid, but her first kid would also have a kid. So now we have the first grandkid. Going to the next period, we have all the 4 parties here, and each would have a newborn. So you can imagine, going to the end, we will have the mother cell, its own kids, grandkids, grandkids, and so on. So the 100% growth is speaking in terms of the unit mother cell, those direct descendants from the mother cell. They add up to 1. So it's obvious the final result must be greater than 2. But what is it? And how small this gap should be in order to be continuous growth? Let's start with the simplest case. For 1 period, we have 1 times 1 plus 1 unit. For 2 periods, each grows a half, so we first have 1 plus a half. Viewing this as a whole, next we have this whole thing times 1 plus a half. Doing 3 periods, we have 1 plus a third first, then times 1 plus a third. And finally, times another 1 plus a third. So if we do n periods, the growth rate for each step is 1 over n. So each step we multiply by 1 plus 1 over n. And the n value would be to the power of n. So for continuous growth, when n approaches infinity, the outcome reaches a limit. We call that limit E. But what exactly is E, and how to calculate it? In the next video, I will talk about how to use binomial theorem to analyze this problem.